Hello guys, welcome to your second experiment for water quality modeling, SWTA021 practical. Today's experiment title, we are going to do the determination of alkalinity, acidity and hardness in water. So we are going to use titration method. As you can see that we have already prepared the slots for the titration method. So firstly we are going to start with alkalinity, then we'll follow with hardness and also do the acidity in water. So with alkalinity, we are going to use phenolphthalein indicator and methyl orange indicator. With phenolphthalein, it depends on the pH level that we have. So firstly, we have to measure the pH of our water sample and check. If it's above 8.3, that's where we are going to check. We're going to use phenolphthalein as indicator. And if it's below 8.3, we're going to use methyl orange as indicator. So let's start by measuring our water sample. This is sample 1. So we are going to measure 100 ml using volumetric flask, using this Aluminium flask. Then after measuring our 100 ml, that's where we are going to, firstly before we titrate, we have to measure our pH. Remember from experiment 1 how we calibrated our machine for measuring the pH. So now we are going to start doing our measurements for pH so that we can see which indicator we should start with. So firstly we rinse our electrode, wipe with a paper towel, then we immerse our electrode and press measure. So we'll see what is the pH of our water sample. As you can see, still processing. So let's wait a few minutes until it gives us smile. So if we get the smile, we will know that our pH is what? It's taking so long. There is our smile. We can see that our pH is above 8.3. So now we have to continue with the titration. So this means that our water sample 1 has got pH of 8.52, which means we have to start by first doing the phenolphthalein titration using the phenolphthalein indicator. This is our phenolphthalein indicator. So before I put in the indicator inside our water sample, I first have to we use sulfuric acid as our titrant. So we have to fill up the burette first. We have to fill up our burette using sulfuric acid. There we go. We fill it up until the mark at 0. so that we can be able to know the volume of our sulfuric acid needed to titrate our water sample up until it reaches the end point. Sorry, it was not close. So we fill it up until 0. So you can see that the measurement is at 0. So now, after filling in our burette with sulfuric acid, we can now put in our 2 to 3 drops of phenolphthalein indicator using this pipette medicine dropper. 1, 2, 3. Let's see. Okay, as we add our phenolphthalein indicator into our water sample, you can see that the water sample turns pink. So I added 3 drops of phenolphthalein indicator. I will add it into 3 LMR flags. This is just to repeat for the accuracy reasons. So we will take the average of this sulfuric acid volume. So let's start by titrating our first beaker, our first LMR flask. So please make sure that when you titrate, your left hand hold your LMR flask for you to shake. Then the right hand, you make sure that you open your burette. Make sure that you do it drop wisely. Drops. So your water has to turn colorless. Has to be colorless as you titrate. As you can see that the water sample is changing color. So that's where you close your burette. And after closing your burette, now you can check the amount of the volume that you use to measure to titrate your water sample. So as you can see that this sample was titrated with 1.6 mils of sulfuric acid. Therefore, that's when you continue with your third burette. Still do the same thing. Left hand, you hold your LMR flask. You titrate, drop wisely. You titrate, drop wisely. So make sure that you have these drops so that you don't put in a lot of sulfuric acid without knowing. So this is your second one. So from 1.6 to 3.1. 1.6 to 3.1. So it means that you're going to say 3.1 minus 1.6. That's where you're going to get your second volume. So then now you can titrate, or maybe you can fill up your burette if you to avoid to minus your volume. So for the third one, let's just refill. Okay. So now you start titrating. Make sure that you do drop wisely with drops. Yes. And you shake your water sample up until it turns colorless. You can see then your third volume is at 1.5. So it means that we have 1.6 and 1.5 for the third LMR flux. Then now we have to calculate the second LMR flux. 3.1 minus 1.6. So now you have to make sure that this is the first trial. The first beaker is for the first trial, the second beaker is the second trial, the third beaker is for the third trial. So first trial, you got 1.6. The third trial is 3.1 minus 1.6. So I don't have calculator. So now you can write 3.1 minus 1.6. We'll calculate it. So now the third trial is 1.5. So at the end you take the average of these three trials to put the volume of sulfuric acid that was needed to titrate sample 1. Then that's where you'll, after getting the volume of your sulfuric acid, you'll be able to calculate your alkalinity in water, which is in milligrams per liter. Thank you. This is the end of the alkalinity titrations. Then we will continue with the hardness and acidity. So after titrating with phenolphthalein, using phenolphthalein indicator, the same water sample, you use the methyl orange indicator. Now you use methyl orange indicator for you to have your total alkalinity. Remember that one was for the phenolphthalein alkalinity. So when you calculate, you must know that the first volumes are for phenolphthalein indicator. Then this one, the one that we are doing now, is for methyl orange, which is the total alkalinity. So now you can put the drops of methyl orange for your water sample to turn yellow. Then now you can titrate. As you can see that it has turned yellow. Now you can start titrating. This is beaker 1. So okay, then now we titrate. We're still using sulfuric acid. Oh, sorry, let me fill the burette first so that we don't do the calculations for this thing. Okay, let's fill up our burette. Okay, up until the 0. Okay, that's fine. Now we can start titrating. Make sure that you check when your water sample turns red or pink. You can see, make sure you do it drop wisely. So you can see that your water sample has changed color. So now we can check the volume of our sulfuric acid used, which is 1.4. So we can write for total alkalinity, we can write 1.4 for the first trial. Then the second trial, we titrate. Make sure that you do it drop wisely. Then it changed to pink. Then the volume from 1.4 to 3, which means it's 1.6. The volume of our sulfuric acid is 1.6 for the second trial. Then the third trial, let's see. Let me refill first. Let me refill to 0. Okay, there we go. So now we can titrate our third trial. So your water turns pink. Yes, then that's where you can check the volume, which is 1.5. So the third trial is 1.5. Please guys, make sure that when you do your second and third trial, make sure that the volume of sulfuric acid used is not, the difference is not above 1. As you can see that the difference from 1.4 and 1.6 is not above 1. So 1.6 and 1.5 is not above 1 for the accuracy reason, since you are titrating the same water sample. So that's how we do our titration for total alkalinity. Therefore, this is only, you only use phenolphthalein and methyl orange indicator when your pH is above 8.3. When your water sample pH is only below 8.3, that's when you go straight for using the methyl orange indicator only. You don't use the phenolphthalein indicator. You don't do it because your pH for water sample will be below 8.3. So make sure that when you do the calculations for phenolphthalein indicator, you calculate the alkalinity, phenolphthalein alkalinity alone, then you also calculate the total alkalinity alone. For the water samples that are above 8.3, but for those that are below 8.3, you only calculate the total alkalinity. Thank you. Then we'll continue with the acidity and hardness in water. Our second parameter is hardness in water. So this is the aim of this hardness, to measure hardness in water. We've determined the hardness of the given sample by EDTA type metric method. So here is our aerochrome black tea indicator, the one that we use for hardness. Then we also have our hardness buffer, which we need 2 ml for each beaker. So we are still doing the titration like we did with the alkalinity, but then here we are using a different indicator, and we are also using the buffer for hardness. This buffer is used to bring the pH level of our water sample to 10. So there is no need for us to measure pH when we are doing hardness, when we are measuring hardness in water. So now we are going to start by measuring 2 ml of our buffer solution to each LMR flask. Okay, let me rinse this first. Okay. Then this is 2. Okay. Here is our 2 ml. Put to the first big LMR flask. This is our second 2 ml. This is the hardness buffer. Then we are done. So before I put in the aerochrome black tea indicator, I first have to fill up the burette again using the EDTA. We are titrating with EDTA as our titrate. So we fill up our burette with EDTA up until the 0 mark. The 0 mark. So there we go. Then we can remove to make sure that the measurements are correct. Okay. Then here we go. That is the 0 mark. So now we can put our 2 drops of aerochrome black tea indicator. So using this medicine dropper, say 1, 2, 1, 2, 1, 2. So we can shake our sample. Okay. So let's put, because they said 2 to 3 drops. So our water sample will turn wine red in color. So I'm trying to see. Okay, fine. Okay, it's fine. I don't know if you can see the color clearly, but here it is, the water of our water sample. So we have to titrate our water sample so that the color, this color tends to from wine red color to blue until the water sample turns blue. So now we can start with the titration using EDTA. So make sure that you do it drop wisely up until your water sample color turns blue. So titrate, drop wisely up until your water sample color turns blue. To how it's supposed to change from this wine red up until you get a blue color. You titrate up until your water sample turns blue. As you can see that the water sample changed color. So after it has changed this color, now we can check the volume of EDTA used. As you can see, that is at 14, is it? No, 13.4. The volume of our titrant is 13.4. So let's refill, since that we can see that for our sample, it requires a lot of EDTA to titrate. So let's refill up until 0 so that we don't run out of EDTA while titrating. So we reached. All right. So let's fill up our burette, then so that we can continue with the second trial. That one was the first trial, but the same water sample. Now we are doing the second trial. You can see. So now we can start titrating. Make sure that you do it drop wisely. Okay, and here we go. This water sample means that it has got a very hard, it's a very hard water which requires a lot of EDTA to reach our end point. So now, as you can see that we are still far from the color change. There we go, there we go. The water is changing, as you can see it. So the water turns blue. So now you can stop your titration after the color change. So as you can see, your water sample turns blue, similar as the first trial. So now we are going to do the third trial. Oh, first, before we do the third trial, we have to know the volume of EDTA used. The first one was 13.4. 13.4 for the first trial. So the second trial is 13.3. It's 13.3. So now we can do the one for the third trial. So let's refill again with EDTA for our third trial. We refill up until 0. Okay, it's at 0. So now we can start titrating our third trial. So this is our third trial. So as you can see that you do it drop wisely, up until your color changes to blue. So titrate your water sample. Make sure that you see it when it changes. You can see that it's coming. So when it comes, make sure that the drops, you decrease the drop. Okay, there it goes. Then we are fine. So now you can see that your water changed to blue as the first beakers. Okay, this is the fine one that we need. So this is the blue color. Okay, let's put the last drop. Okay, then as you can see, our water sample tends to blue at 13 point, what's the 6 or 7? 13.6. So the third trial is 13.6. So that's how we do our titration for hardness. So this is the volumes for hardness. Then you can take the average of your volumes of EDTA. Then you write your average here. Then you calculate for your hardness as calcium carbonate with the units of milligrams per liter. Okay, then guys, the method in your practical manual, you can see that the title is saying that you have to do alkalinity, acidity and hardness. So for this experiment now, you're only going to do alkalinity and hardness only. Then we'll do acidity some other time. So now I'm going to measure these parameters for sample 2 and sample 3 for both alkalinity and hardness. So I will send through the results for alkalinity and hardness so that you can be able to calculate the alkalinity and the hardness in these 3 water samples that you have. So I will send through the results when I send the video for these practicals. Thank you. This is the end of your experiment.